Hey yo everybody, welcome back to another live stream. This is the 20th episode of Becoming a Musician. We're only... Okay, I'll stop making the same joke in every intro. Welcome back, and it's good to be back. It's been like, what, 4 days? 3 days? Something like that. I took a little break because in my latest stream I was just basically dying at the end and couldn't progress. I was just blocked, but I unblocked myself and made some progress. So I thought it's a good idea to be back and just keep grinding on stuff. And this has been okay. I have exciting news. First of all, I bought a proper jack input. If you remember this little fellow over here, I tried connecting my guitar to this. It didn't work. But it turns out, surprise, surprise, it was due to another reasons. But I was so fixated on my jack input that I didn't see the other problems. But yeah, I have a proper one now. This is also the one that I used in the guitar pedal that I assembled. So I have this jack input. And one thing is that accidentally bought stereo. That kind of sucks, but yeah, whatever. Just don't use one of the tips. What are you gonna do? And I have actually a bunch of them. I don't know why I bought like a lot of those jack inputs. I don't think I'll use many of them, but anyways. So the news are, if you know my guitar guitar project, now you can just simply plug in your actual physical guitar to it. You don't use this microphone input anymore. I was using this little microphone for the input, so the idea was I put this thing on the guitar, and this little microphone picks up the noise and picks up the audio and just converts it to frequency graph signals, and then you can see the notes and stuff. It works, but I thought it would be cooler to have an option to actually just plug in the guitar and see everything. So that works now. I'm gonna show you how it works. And actually I'm not sure if I made any changes in the code. Maybe we can just take a look at that real quick. I don't think I did, but let's see. I might have changed the graph a little bit maybe. I have a pin map of ESP32. I'm just gonna save it here. I don't think I'll commit that. What did I change? Actually, I didn't change much. I just changed this waveform thing, like change the range for that, and it's just like a very small change anyway, so that's fine. Yeah, so I didn't really change anything in the code. It was mostly just electronics, I guess. So yeah, 1 second, something is not working here for some reason. I'm unable to run my cooler. What is going on? Is it broken? Okay, now it's running. It's kind of weird. It's not kind of weird, that's actually quite weird. Anyways, I'll show you my progress now. So, first of all, I need to switch to another camera. Let me just do that real quick. Let me just switch to my POV camera to the desk so that you'll see everything nicely. Oh shit, I'm just plugging it, guys. Let me just plug it and show it to you. Everything is on breadboard. That's why we're doing the stream to draw the actual circuit. I'm not sure if I'll able to do everything in the stream, but at least I just wanna start working on it and see how it feels like to design PCBs after what, 20 years? No, not 20 years. What am I talking about? 10 years? I'm not that old, come on. 10 years, it's been a long time. The last circuit that I draw, like last PCB that I made, was in a program called Eagle, and it was like a programmer, a microcontroller programmer circuit, and it was painful times, man. Painful times. Okay. All right. Give me a second. Okay, so we can just switch to the other camera now. All right, guys. This is the. Okay, this is the worst camera angle ever. Okay. Oh shit. Anyways, I'm just gonna hold it like that. So this is what I have, everybody. This is what we're working with. I have a bunch of components, breadboard. This is the ESP32. I just realized I have many USB cables over here. I don't know why I have many of them. Just get rid of this. So, guys, so we connect the guitar to this little fella. Let me just power this on. Actually no. Let me just give you an overview of the circuit. So, you see there isn't much like connections to ESP32. There's only like, 3.3 volts and then just the analog reader. And what I'm using here is that there's this little let me just use my magnifier thing. Actually, that would be cooler, I think, to show it to you. And also it's much more quality video now for some reason. So it's a mess. I know it's a mess, but just bear with me. So this is right here. This is LM. What was it? LM356, I think. LM356, if I remember correctly. And it's basically like a op amp, and that's just being used to amplify the input signal. And I have some potentium pot. I have a pot right here, 1 million. This is for adjusting the gain, so it's changing some value of some resistor here, so adjusting the gain, so you can play around with this to read the signals better and so on. And I have a bunch of voltage dividers. These are like the resistors for that. And also I am using this diode to protect the analog input of ESP32. This was necessary because it turns out that 3.3 volts is not enough to amplify the signal that is coming from guitar jack. So what I did was I actually connected the whole LM358 to 9-volt battery because it can operate from 3 volts to I don't know, I don't remember the max voltage, but you can basically run it with 9 volts. So I have connected that to 9 volts. So I connected the ground of this 9-volt battery to ground of ESP32, and I don't want to burn the analog reader on this. That's why I have this diode that limits the output of the amplification to 3.3 volts, so you get like proper values and you don't just burn your ESP32. So there's that. So that also works with some kind of a voltage divider, I think. And what else do I have? Oh, I have a capacitor for bias, like it's just better for better reading, and that's the whole circuit. I know what I have here, but I probably need to just take a look at this breadboard while I'm drawing the actual PCB. So let's run this and see what's gonna happen. So I'm gonna connect the battery. 1 second. Let's connect the battery. Boom. So now the chip is being powered, and let's connect the ESP32. We are not reading any signal because we don't have the guitar connected to this. So let me just do that. 1 second, guys. Okay. Boom. It's alright. So now it's connected, and I'm still not reading anything. That's kind of concerning, actually. That's actually quite concerning right now. Okay, so okay, something's going on. Dude, when did this thing break? It was working, I swear to God. Okay, there you go. Something's happening. I'm not reading any signal from the guitar, actually. Why is that? Okay, now it's doing something. Just play around with the potentiometer. Alright guys, electronics debugging time. That's fucking fun. Oh my god, and what happened? This was working last night. Okay, let me just fix the camera. 1 second. 1 sec. I need to somehow stabilize it so that you see what I'm doing. When it started, that was a really nice looking output in the screen. Okay, so yeah, let me just fix this now, I guess. So 9 volts. You gotta make sure everything's going right here. Maybe I touched something and that fucked something up. I don't know. I have no idea. Let's see. Just gonna move things around a little bit. Okay. So I'm gonna actually do this properly and just use a multimeter to see the values. Okay, so just connect this. First of all, let me just check the battery. Still 9 volts, nothing has changed over here. Okay, so now so many stuff on my desk. Okay, let's check. I guess the voltage here. really hard. I'm not reading anything actually here. Let me check here. What? Okay, let me just power everything on and just check that way. You see, it's not reading anything here. That's a problem. We should read some value. We should read some value there. Let me check the voltage here on the VCC and ground. It's 3.3, okay. About here. This should be that's very weird. That's weird. So this goes to here, and where's this other thing going? Okay, so if I check, I should get like 9 volts from here. Okay. Yeah, 9 volts. So this chip is now being powered. That's for sure. Oh, we have some voltage. It's so weird, man. Maybe it's because of the jack. Okay, you know what? You know what? I don't know what's wrong. It actually does something when I touch the string. But wait, it's a bit weird. The gain is so low. Is it possibly because of the power? Wait a minute. Maybe that's why. Oh shit. Okay, I think that's why. Just gonna connect this directly to this adapter. You guys see this move? It's actually okay. Wait, I know what's wrong. It's actually working. I don't think the gain was this low though. I'm not really sure why that's so low. I mean, in the video that I recorded yesterday, let me just check that real quick. It was definitely higher there. Yeah, it was around 1.1 volts. It was around 1.1 volts. Why is it like around 800 now? What the hell? I didn't change anything since last night, so this should be just fine. Let me actually flash this again. 1 second. One sec. Embedded. It's gonna be the release mode. I have no idea why the gain has changed since last night. I am so lost on that, like why, dude. Okay, it's flashing. Taking forever, as always. Come on, dude. Just takes forever. But I think now it will work and we'll see the notes on the screen and so on. Still, I'm clueless about why the gain has changed, but I'm trying not to think about it because otherwise I'll go crazy. And we're just gonna debug this for an hour, so let's not think about that. Let me just show you how it looks like. Just power it on. So empty string. Not sure if you can see it though. So many cables. I can just amplify it for you. There you go. So alright, it took me 30 minutes to show you what I built, but there we go. So I'm just hitting the E4, B3, So it works. The other stuff also work. Also, one other exciting thing, now we have this note overlay, so it kind of looks bad, but when I hit E4, you see it slightly here, so it actually is being shown on as a tab. I should make it show better, but you know, it works, so you can fix it later. So E4, you see the tabs. I'm just gonna try to show you. Yeah. So yeah, I can now connect my guitar to this, which is great. So that's the progress. Let's try to design the PCB for this, because I don't want to just put the whole breadboard into a case and then call it a day, you know. I'm just gonna unplug everything, hoping that next time when I try this out it won't break, but you never know. It's electronics, so anything can break. But if you make a PCB, it's gonna be more robust. Alright. So for the PCB, Yagoda, friend, the author of Mouse Food Framework, she suggested I use Easy, EDA. What is EDA? I don't know, but Easy. This one for PCB, and it didn't have dark mode, so I'm just gonna really quickly try to add dark mode to it. I don't wanna bleed from my eyes, so yeah, let's just try to do it. So what was the downloaded file? Easy. Oh shit, it just... the hell? Oh my god. Maybe I should have just tried to load a zip file. Okay, let me just run this thing. Oh shit, my eyes are bleeding. Alright, so how do I load a theme? Advanced extensions. What? Extension settings. Load extension. Select files. Select this one. Select all files. Okay, I need to unzip this then. Okay, okay, select files. Extension ID, themer, theme settings, and select theme. Okay, nice. How do I go to the theme settings? Okay, Dracula. It's actually a really bad theme, but one light. Oh shit, it's light theme again. Solarize dark. That's bad. This is nice. I like it. Alright, thank you. I'm gonna give you a star. Thank you for the theme extension. So this is my ChatGPT chat for this project. And yeah, I don't know how to use this, but yeah, let's try to use it. So standard mode. Okay, new project. Title Twitter PCB. Description, no, just save it. Okay. Man, this UI is so bad. We should have a terminal UI for this. Space R to rotate the placing object. Close it. What the hell? Okay. Wiring tools. Draw. Design manager, common library. Okay. So let's do this. What do I have? Let me try to find it. LM. Do we have this? P. I have the P one, right? LM358P. If I remember correctly, that was the chip. LM358P. Okay, that's the chip. Where's the P? Dude, just P. Which one is it though? Do we have the just P? Yeah, I'm just gonna use this one. Yeah, exactly. This is what I want. Give me that. Alright. Oh shit, a huge moth just entered my room. My window's open. Wait, guys, I don't wanna get invaded by Mothman, so I'm gonna close the window. What even are you, bro? You're so big. Okay, replace that. How do I zoom in? Can I zoom in, please? Oh, okay, I did that somehow. Okay, you can just zoom in like that. And you can just, it's a bit weird controls, but okay. What do I need? A potence pot. Actually, I'm thinking if I should add like a bigger pot, like 2 million maybe, or something. Design manager. Actually, maybe there's an easier way to get this thing as a PCB. I want to get a PCB from this breadboard design. What is the easiest way of doing that. Just curious. Yeah, that's what I'm using right now. Use the breadboard to PCB workflow. Oh wow, okay. That's fucking nice. So do I only need to wire everything and then what do I press? Convert schematic to PCB. Oh shit. That's sick. Okay, I'll try that then. Alright, so okay, I'm motivated now. Let me just keep going. I'll use easy Ada. Give me a rundown of the components and connections. I just want to make sure that everything is fine. 10k resistor, 10k. Right, let me just add everything. So 10k resistor, I need 2 of them, right? 10k common library resistor, 10k. How do I do that? So what is this? Library 10k res. How do I find this? I just need a resistor, man. Please click the part and move the cursor to the canvas, then right click to place. Okay, okay, that's nice. So 1k I need 2, and I need to make this thing 10k, 10k, 10k. I need RV1 potentiometer. I really don't know how that looks like on a circuit actually. I'll just try to find it. Okay. Actually, this should be it, I guess. RV1. Is this a pot? RP1. Potentiometer PCB. How it looks like, I don't know. Symbol. Yeah, that looks like it. But which one though? I'm just gonna use this one. How do I change the text? 1 million. Okay, moving on. Just realized my camera is just a bit off. 1 second. Okay. What is our bias? 10K, 10K. Oh, it's all 10K? I just use 1K though. Anyways, capacitor, let's add a capacitor. The value is 1. What is the value? I think it was 1 microfarads. Yeah, one microfarads. So 1 U. Okay, there you go. Oops. And this diode 1N5819 library. I think that's it. There we go. And what do I need? That's that. J1. How can I find this actually? What is this? Jack, DC jack, power jack, mono jack, okay, maybe this one. What is this actually? I don't think this is what I want. Can I just have like a arbitrary connection? How can I do that? Just have an arbitrary connection, man. What if I just search for J1, dude? Connector. Yeah, let me just use this. Mono jack. Let's call it J1. And this is gonna be ADC out. power and ground. Okay, that's enough. Okay guys, so we start hooking up things now. Well, I need 2 VCCs. That's gonna be interesting. Can I actually power? Can I power ESP from that 9-volt as well? Okay, what is this? Linear voltage regulator. Okay, let me not think about that for now. Let me connect everything. So VCC, ground, regulator, can I just do this? Let me backseat engineer. What? Okay, we're just gonna connect like this, I guess. So, okay, let's go. 9 volts. Is it directly 9 volts though? What is this? 5 volts? Let me check. Yeah, it is directly 9 volts. So we're gonna change this to 9 volts. Just VCC 9 volts. There you go. It's gonna go to ground. Ground. Why is it so annoying? Yo, how's it going? It's going, bro. Somehow it's trying to go. How about you? How are you doing? It's gonna connect this to ground. Right. Pin 4. Okay, that's that, and with that we just powered the circuit. Guitar input, jack tip 1, capacitor to pin 3. So 1. So the second one just goes to ground. Let me just connect that. Where's ground? That's flag. Can I just do that? Okay, just ground. There we go. The second one going to ground. And the first one actually goes through a resistor. That's 1K for some reason. I don't know if that's needed, to be honest, but that's fine. And then we basically take that and put it in series with the capacitor. Just double checking this on the circuit. And just connecting like that. Just started an internship at the defense industry, and after 2 weeks got a candidate engineer offer. Life good at the moment. That's nice, man. Congrats. And that goes to the third pin input. It's gonna be a bit of a weird wiring. Maybe I should have just placed it here. No, that looks bad. Okay, just move everything a little bit, because otherwise this won't work. Third pin, there we go. Okay, and that's that. Biasing U1 pin. U1, what is U1? Pin 2 connected to midpoint of RBS 1. Okay, what? The second pin is just the middle point of two resistors of 1K from... Okay, got it. So... something like this. One of them will go to ground. The other one is going to be just VCC. Oh, come on. It's so hard to control. Yeah, something like this. Just go to pin 2. That's like the bias. So it takes the voltage and divides it in half, I guess. Just double checking this on the breadboard. Looks okay. Looks okay. Gain control. So one side, pin 2, and 1 and 2. 1 and 2. Okay, so potentiometer, where is it? Oh, what did I do? Okay, so just gonna place it there. So I need to see an example connection. 1, 2, 3. Okay. Middle pin leave unconnected also to in for stability. Okay, got it. So one side U2, U in and out. Okay, so in and out. Can I rotate this? Oh, I can. Dude, I was just suffering for no reason. I could simply rotate stuff. Okay, I learned that a little bit late. I learned that actually quite late, but fine. Just connect, man, what the hell? Okay, there you go. That's the gain control. That's the gain control, and I need to connect the output, I guess. U1 out R1 divided node. Wait, what? Okay, I know what to do. So we have two resistors, right? One of them will go to ground. Let me get the ground. And the other one is going to be connected. Connected to output. Oh no, not to these guys. Delete these. How can I delete this? I don't want to add a connection to these. Oh no. Why is it happening like that? Okay, maybe I need to do like this, just from here. Oh no. Okay, that worked, I think. And the middle point of those things gonna go to this diode. So the voltage is divided or something, and then we're gonna add this diode for protection. But I don't know. Okay, diode symbol PCB. Okay, that's what I needed. I totally forgot about these details. So this stripe is on this side. In my case, it should be something like this. Yeah, there you go. And then directly to the output. Okay, how do we power this? We need to add 2 more connections. For actually, I don't know. We can try to get a PCB from this now. There's some unfinished nets. Do you want to check the nets? Yes, check nets. What is nets? 9 volts. Incomplete net. A complete net should contain 2 or more pins. If you designed it on purpose, please. What? What does that even mean? Oh, these ones? Oh, these ones are not connected. That's what you mean. Actually, I don't know. Not sure if I need to do anything. Easy era. Should probably watch the tutorial first. Just save this. Is there an example? Anyways, I don't know. We can just ignore that. Yeah, just apply whatever. So what is this now? What just happened? Dude, I don't know what I'm looking at. What the fuck? That's perfect, dude. They're just floating now. They're floating. I love it. I love it. Okay, just close all of these things. What the hell, man? Just put them on a board. What the fuck? Just make the thing bigger. Okay, now are they on the board? Yeah. I'm so confused, dude. What the hell? Why RP1 is so gigantic? What is RP1? Oh, that's the potentiometer. Okay. I think this is like the worst PCB design ever. Man, I need to watch a tutorial. I need to watch a tutorial. I just YOLO'd it and it didn't turn out great. I don't know what happened there. Maybe I should have just used the breadboard to PCB editor. Do I have an online editor? Design online, let's do that. Free? can probably just import this project. Okay. Import professional, import standard. Oh, I need an account. Open project. Do I need to log in for this, man? This is kind of annoying. Okay, let me just sign up real quick, guys. Give me a second. I'm signing up. Okay. I'm signing up to be able to design PCBs now. Okay, I'm trying to log in. Oh my god, so many options. I don't want anything from you guys. Just let me just log in. Skip everything. Okay, new project. Is there like a really like a breadboard to PCB type of thing? Wait, what did ChatGPT said? Use a breadboard to PCB workflow. Place parts from the parts library, wire them and schematic view. That's what I did. Didn't do anything. Update PCB, what is this? This looks horrible, dude. I really need to watch that tutorial, I think. Okay, let me just watch it.
It might say that there are some unfinished nets. Do you want to check? And we know unfinished nets means there's some kind of empty things we didn't hook up, and that's okay. That was intentional. So let's keep going. Okay, now at this point it says, great, let's create a new PCB. And we can leave these values default, they should be okay. And so we can go ahead and hit apply. Okay, we kind of zoom out. One of the very first things that we're going to do is we're going to come over here to units, and we're going to make sure that these are in millimeters. In terms of making things a little bit easier to see, we're going to change our grid size. I like to have a 5mm grid size. And for my snap size, I'm going to set snap size to 1mm. And that just means as we kind of drag things around, a little bit easier to see where they're going. So here are our components all kind of floating up in here. And you might notice that these actually look like real components now. And there's a big kind of purplish pink box right here that kind of shows us, I'm going to minimize that for now, shows us the outside edges of our printed circuit board. And so our job is to get all of these components organized neatly in here. And you'll notice that these components are hooked together with these little blue kind of, stretchy elastic lines. What these are doing is showing us kind of guides as to what components need to get hooked up with each other. But these aren't actual solid connections yet. Our job is going to be, once we've kind of placed our components, to actually go and create these solid copper wires that will be embedded in the board that will make all of these electrical connections for us. And so one of the very first things I'm going to do is I'm going to move my little Arduino to this side of the board. That seems to be a pretty good place for it. And I'm going to move down all of these components. And again, there's kind of some
bro looks so
assumptions that
locked
we can
in.
make. So
Absolutely.
there's a little switch, and I can assume that my switch is going to go near this resistor. So I'm going to place them relatively close to each other. And I'm going to bring my LED down and my other resistor down.
So you're just placing the components
I'm gonna
now.
place them right about
How are you
here.
gonna do the wiring, dude?
Okay.
I'm
And so
curious about
one of
that.
the things I want to be on the lookout for is kind of places where it seems like maybe the wires are getting tangled up or twisted. These don't look too bad, but if you do get a component that seems like it's in a weird orientation, you can select on it and hit the R key, and the R key will kind of rotate it around until the wires don't look so twisted anymore. So again, here, I'm just going to kind of explore around a little bit and see if there's any kind of rotations here that make things a little bit nicer for us. So it doesn't have to be perfect, but it should just try to be close. Okay. Now at this point then, let's go ahead and see if we can start making some connections here that will allow us to complete this circuit. One thing that we want to double check is that over here in routing conflict that it is set to block. And what this will do is it actually will help us physically prevent us from making a mistake. So I'm going to get started, and I'm going to start here up with my switch. Now again, like before, I need to kind of make a physical connection here. So I'm going to come over to my track tool, and I'm going to start here, and I'm going to want to follow this blue line across. So I'm going to click here, and I'm going to add in a little bend, and you can see that blue line suddenly turned into a red wire. This represents a real copper wire that's going to be embedded in the board. Okay, well now let's look to see, I'm going to make this other connection over here from our switch over to our resistor, and now that one's all hooked up, which is pretty good. Now we've got a problem here. If I come over to this, and I come over and I try to follow that blue line, you can see how it's wanting to get to the ground, but it won't let me actually connect to it. And what's happening here is, if I zoom in here, I'm trying to kind of cross over this previously existing line, but it's not going to let me do that. There's a physical barrier now there because there's already a wire there. So we could try to kind of snake our way through these little spots, but it turns out that on circuit boards, there's a top layer that we can put wires, and there's a bottom layer that we can put wires too. And so if I run into this issue of needing to kind of get from one place to the other and it just won't let me through, I can click on this little blue layer, and you can change this pencil to it. We can click on our wire tool, and now, since I'm working on the bottom layer of the board, there's no problem there with kind of crossing over that.
Damn.
And so that's going to help you make connections where they may otherwise be kind of infeasible. Okay, let's look at this other side of the resistor. It needs to come all the way over here to D3. Okay, well I could choose what side of the board. I'm going to work on the top layer, and I'm going to click on that, and I'm going to work my way around the board, and you can click along the way. You'll notice that I am trying to avoid making 90-degree angles. In circuit design, 90-degree angles are actually kind of bad. And so I am trying to kind of keep, 45-degree angles as much as I can. But you can see now that that's hooked up all the way over there, and it doesn't run into anything along the way. So this actually kind of becomes a game for kind of how can you organize your components, or how can you route your wires in the way that's most efficient but also avoids collisions. So let's kind of come down over here. We've got our resistor and our LED to hook up. Okay, well, looks like my LED wants to come over here to D2.
We got the idea.
LED and my resistor. It's like I'm in pretty good shape here. It looks like I don't have any of those little thin blue,
what?
they're called rat's nest lines. Everything is a solid wire now.
Did he say rat?
Here, it looks like I don't have any of those little thin blue, they're called rat's nest lines. Everything is a solid wire now.
Red or
and so
rat?
I'm going to go ahead and click save.
Anyways.
And we want to kind of double check a few things to make sure that we have, in fact, got everything connected. So if I come over here and click on Design Manager, if I click on Nets and I click this little refresh button, okay, I should see that I've got 33 out of 33 connections. If there's any X's there, it may mean that you've kind of missed a connection or you've made a small mistake.
Rat's nest lines.
Next thing is we're going to do what's called the Design Rules Check Errors. And so we're going to hit that refresh, and it's going to check, and looks like it didn't find any errors. So that's great. And so at this point then, we just have one final thing that we want to do, and that's that we want to look at our circuit in 3D. And so there's a 3D
Do that.
right here, and we're going to click on that. And it's actually going to render our circuit board in 3 dimensions, so we can kind of see those little traces that'll be made. And again, these are just like the circuit boards you guys will be soldering today. These can get manufactured very inexpensively, and it's a great way to kind of make a more permanent version of your circuit. And this even lets you change your the color you want. So if you want like a purple board, you can get a purple board.
Shit.
If you want a yellow board, ooh, that's very bright.
That's a flex.
So you can even change the color. So at this point, what you're going to do for your documentation is you're going to want to take a screenshot of your
That's
schematic
nice,
view.
bro.
Okay.
I like that.
See what these will.
All right, I'm done with the tutorial. I'm hyped now. Let me just draw the lines, dude. Let me just draw the lines. I'm gonna find a nice music. Tech cam music. That's what I want. That's exactly what I wanted. Circuit drawing type beat. Let's go. So first thing that I realized on this PCB, this RP1 is huge, and that's not good because I'm not gonna use a huge component like that. It's just three it is just 3 legs and just next to each other, so I'm actually gonna change that to something else. I don't know if I'll be able to find it, but RP1. Potentiometer in this library, man. Yeah, this looks better actually. Precision potentiometer 500 ohm. Which one should I choose? Rat's nest is slang for tangled. Got it. I think I'm gonna go with this one. Let's rename this to RP1. Complicated, yeah, I know. This is gonna be 1 million, dude. keep it 1 million ohms. Remove this, put it over here. Alright, now let's see the schematics now. So this guy changed the grid size to 5 or something. I'm just gonna keep it as default, or maybe just 2. Hey, hell yeah, dude. So I'm not sure if this is actually correct representation, because probably not correct representation, because these holes are not like that close to each other on the breadboard. It takes like double the amount of holes that we have here, so that's probably not the correct thing. Okay, let me try this one. Let me try this one, maybe this will work, I don't know. But no, this is not the same though. Just keep clicking this. Anyways, why can't I find it, dude? Can I change this? Customize the gap between the legs or something? Can I do this here? Somehow? Okay, easy. Hit a put. Yeah. Shouldn't be that hard. P1 million. Maybe I should just search for P1 million. P1M. P1 million. I'm not the only one. Footprints. Import. Actually, 10k would be also would probably work too. Is this the same? Yeah, I think it's the same as the other one. So, this is what I need, okay? Let me just show you. B10K. Maybe I can just like search for like for this. So this is what I'm trying to find. B10K. Okay, that looks kind of promising. B1M actually is the exact name. God knows which one it is. I think this would work. It's worth trying. You update PCB. I don't think this is correct. We'll save. RP1 1M. Just give me the PCB, man. Okay, now it looks like... Wait, actually, am I fucking stupid? I'm not gonna put this on the board. I just need like 3... Oh my god, dude. I'm stupid. Doesn't have to be like that. Okay, whatever. That should be fine. Okay, that was painful for no reason. There we go. So we have a gain control, 5, 4, 5 resistors. Jumpers. No, it's not jumper. This is actually okay. Let me just try to do this. Okay, I'm gonna place it like this. So where's the ground and VCC connections? I don't see any ground or anything. It's kind of bad. Maybe I should have watched the end of that tutorial. Maybe he said something about the ground connections.
Okay, so today we're going to learn how to do that design rules check again, and we've already really quickly done that.
You can just order it from
3D,
the
so you can kind of pose it in a really cool angle.
editor. What?
That for your documentation of your PCB design view, and then you're going to want to take one last screenshot of your 3D board, so you can kind of pose it in a really cool angle and take a picture of that for your documentation. circuit.
Dude, where's the ground connection stuff? Then you start as a tweet to visualize sound, turn into USB, now designing PCB. Yeah, it's going crazy, man. It's going crazy. Power supply. That's kind of interesting. Still not sure how to get the VCC and ground working. You should connect ground nets with either wires from the wiring tools or a ground symbol. You have joined them with a network. Check the nets. Let's check the nets. 9 volts is not connected. These are not connected. That's fine. VCC is not connected. Yeah, this is my problem. I don't see any pads for the ground on VCC. Because of that, I had to create a single pad and use that points. But I'm doing something wrong. Yeah, okay, that's exactly what I'm asking. If it's on or forms an integral part of PC, then it must be represented by a schematic symbol in the schematic of PCB point. What? I don't get this answer. Let's see the links. So what did this guy do? Basically created 2 connectors for that. Did you have them in the schematic? Yeah, I have them here. Like ground and VCC. Why is it now working automatically? I'm gonna read this again, I don't get it. Package attribute of that symbol, what? What is pin? I don't know. 2, 2, 2, 3, 4, and 6. Well, this has been... Anybody has used this before? I'm kind of confused. How does one assign VCC ground to read PCB conversion time without tying either power pin to a power supply? Yeah. Add the VCC and ground pins to the schematic symbol as normal when constructing a symbol for an IC. Okay, what? Okay. Power supply. Yeah, I'm kind of confused here. I need to see it. Maybe there's a video for that.
PCBs that has been manufactured. Secondly, many places.
What are you talking about, man?
This is how our PCB looks before putting a ground plane, and this is how it looks after putting a ground plane. We have to use this tool when we have to put a ground plane. So just click it once.
I don't think this is what I'm looking for, like what I'm searching for, but I'm gonna watch it either way because he's cool.
So this ground plane or copper area will be put on the bottom side. So just then I'll start the other line. So it just creates a square or a rectangle.
This guy is so advanced, man. I look up to him.
Where it has been put. So if I choose top copper, it's good, but top side.
So pro, so pro.
If I delete it completely.
VCC connection. Maybe somebody made a video for this.
Here we have our common library. In it, you have basic parts. Resistors, caps, inductors, and so on. You can't click and drag. Only click the component, then place it.
Dude, this is like...
Here we have our
this is like unuseful as fuck, man. What the hell?
Resistors,
it's like...
caps,
what the hell? That was just...
Here we have
basic, like the most basic and maybe below basic. Okay, maybe I can just
lot of requests to make an
Learned from this.
the same.
Okay, it's doing something with the ground.
And the VCC icons. So drag those to your circuit. The parts of the circuit that have the ground icon connected will be connected together. But if you have two ground icons and you change the name of one of them, they won't be connected together anymore. Now let's make a few connections. From the Tools menu, select the wire, which is the first tool. Click the first point and then to the second point, and now these are connected one to each other. As you can see, I'm using multiple ground icons.
Wait, maybe these are not connected. This looks connected to me.
Icons. So all these wires are the same. Okay, now we have a few connections, but we need more. With a lot of wires, the schematic will be ugly and you won't be able to understand it. So for that we use the labels. So now select the net port tool from the menu. Place that on the schematic and now double click the name and change it. I will name this, for example, reset.
That's interesting.
Now I connect this to the first point. Then I copy the port with Ctrl C and Ctrl V. If you need, you can press the R key to rotate it and place it on the other side. Now make the connections.
Yeah, maybe.
And now this part of the circuit is connected to the pin PC6 of the Atmega chip without any ugly wire. So using these net ports, we can create a good looking schematic even if we have a lot of connections. As you can see here, in one of my schematics for a project, okay. But now what parts for power, for outputs, main ICs and so on. But now what about if you don't find the component that you need?
Okay, just skip.
Now I press the R key. Our pad.
Just create a PCB, come on.
Place one pad on the design canvas and make sure that we will work.
It's not generating the PCB. It's just doing it
0.9mm
from scratch or something.
Select the icon. Save the schematic and now we can pass to the PCB layout. For that, click Convert to PCB button in the top menu. This will create a new PCB design. Click the Save button, select the project. Now you can place all the components wherever you want. But let me give you some tips. The ICs and components with a lot one side like
okay, where's the
one.
ground and everything?
The outline, width, and the and it will 45 degrees angle for the track and can in order to withstand more current. Okay, fine.
That was not helpful. Okay, let's check this one.
Hello friends, welcome to Easy and bill of material file one, so you can change the size and shape of PC. Is blue and like this.
Okay, that was also not helpful. Let's see. Okay. Okay, I think I know what's going on. So I need a single connector. Okay, where's the connectors? Connector. Okay, let's have this one. So connector 3.3 volts. So how do I add a net label? Net port. Can I just connect this to this maybe? Would that work? Okay, update. Just gonna regenerate actually. I think that worked, yeah. Okay, that's cool. So that worked. So I need connectors now. So that's 3.3, but I connected 9 volts to it. That's kind of bad. Actually, 9 volts ground. It's gonna be like 9 volts. Yeah, I can just name it VCC, but I'm gonna add another connector. Disconnect, man, what the hell? Oh my god, this is annoying. Come on, okay. I just want to move this away. Come on. What the fuck? What? What the hell? Okay, I just need to move them individually then. Oh my god, are you serious? Okay, there you go. Arrow keys. Thank you, man. You saved my life. Thank you, Namco. I was just losing my mind over here, and you just came into the scene like Jesus Christ and just saved me from the pain. Thank you. I'm gonna save this. Let's YOLO the PCB. Let's just YOLO it. I don't know. Let's just YOLO it. Connector. I'm actually gonna change the name of that. It looks really bad. Oh my god, what is this? Get out. Little bug is just flying in my room because I needed to open the window because it's too hot today. Just sweating from my, you know. Oh, I just realized I'm connecting it to the. Oh, this is kind of bad. Probably change this and just connect it the other way around. Yeah, something like this. Okay, this is looking okay. How do I scroll up? I need more space. I really like this music, whatever this is so great. Who's this? I heard this before. Anyways. It doesn't have to be precise, I'm just YOLOing it, so just YOLO. What is this resistor, man? Why is it going to the third? Oh, this is a capacitor. And this is a resistor. Okay, so this is like the jack input. Right? Yeah, okay, I'm gonna just place it over here, I think. I'm gonna place it over here. I think the resistor here is unnecessary, but guys, remember, this is not like the final PCB. I'm just like getting a feel for it, and then probably gonna work on this a lot more later, but now just like, you know, just freestyling it. .3 volts. Probably makes sense to place the the inputs, like the 9 volts and 3.3 next to each other, or no? 0 to 1 is always the hard part. Yeah. Agreed. It's kind of bad actually. This is like the outputs to like the analog output, right? Just gonna place these next to each other. Can probably use the other side of the board or something. Why is this connected to everything, bro? What is this resistor? R3. Okay, found a nice placement. Some nice placement. I think I'm just gonna play that one on repeat. Let me just find that song and I'm just gonna play it on repeat. I just like that. I just like that. Okay. There you go. So right now the only problem that I'm seeing here is that nothing actually. Okay, I think this is good placement. Alright, I'm just gonna wire everything and just see how it's gonna go. Let's do that. The grid is a bit weird though. But anyways. Just center this. Okay, this is better. Oh, I don't like the placement of this actually. I'm gonna remove these. Okay. You can have everything more compact later. Actually, you can do them now. Why is it lagging? I was watching a pub so he was saying don't try to make V1 small, just get it working. Yeah, it's a good tip, but I'm aiming for production right now, straight up. Who gives a shit about beta or testing? Just going production, straight to production, mass production. Actually, I'm just gonna mass produce this. I'm gonna order like 100 of this. Just kidding. That would be crazy. Just imagine, just ordering like a broken one, 100x. But that's just me. That's just me. Oh shit! This resistor's so painful, man. What the fuck? Okay, this can go here, and this can go. Why is this here actually? My thought was I was like planning to just have this thing wired up to here, right? And then have this wired up here. Have this wired up here, then I need to rotate this. Just rotate it. Can wire this one to here. This guy to here. Boom. This live stream is not about becoming a musician anymore. These live streams are now about, I don't even know actually, it's just about electronics now. It's the worst route ever, man. What the hell? Word. I mean, I guess it's alright. Alright, we fucked. I don't know. From here to here, I guess. here to here, I guess. It's a lot easier to get paid for electronics than music. Dude, I don't know. This is so funny, actually. I was not planning to do any of this when I started out with this series. I just wanted to make music, but now I'm just doing PCBs, man. What the hell? Somebody tricked me so hard or something. Maybe I tricked myself into thinking that doing everything from scratch and just following my dreams of doing some creative stuff with music in the meantime, making music is gonna be the path to becoming a musician. But maybe I was just fooling myself and just... I'm not complaining, by the way. I don't know what I'm saying. I'm just yapping. You can call me Orhun. That's like, are you making a reference to that Daft Punk song? Dude, this is like life, you know? Like, this is like life. You just wanted to do one thing and just there's like bunch of things in your way, and then you kind of forget or like distracted to do that one thing and just doing a bunch of other things. Yeah, you should make that into a real song with AI. Okay guys, it's fucked here. Well, what do I do? How do I even connect this? I don't want to draw on the bottom layer just for these connections. Maybe there's a way. There's a way to do that. This is ground, right? I'm thinking. Oh my god. Can I maybe just go all the way around? This is kind of problematic though. Can I? No. Can I just... oh shit. Can I just do this? Just like that? Hell yeah, bro. This is what I'm talking about. Pro electronics. Okay, where this was going? Okay, here. It's great. If somebody looks at this PCB, I'm gonna just get crucifixed or something because of the ugliness of this, but if it works, it works. Well, this is quite bad. This is horrible, actually. Any ideas? Maybe I can just turn this around. Okay, this made everything worse probably. Can't you make those routes into a single one and connect them as a single? Which routes you mean? I'm gonna delete this one actually. Oh, I have an idea. Am I stupid or something? I can just like... Wait. I know. I got this. Oh. I got this. Yeah, on the other side of the PCB, that's what I'm trying to do. Other side seems most likely to work. So I just need to get this here to here and then here, something like that. I don't know. It's not the best, but can't have everything in life, I guess. And then what? I think the previous version was actually easier to solve because I'm just using this side. Man, my brain stopped. I'm scared. Okay. 7 bridges of Königsberg. Okay. Some like this. We're trapped here either way. If I connect this to here, I need to test if I can remove out the resistors. if this doesn't work, just remove them, bro. Just remove them. You don't need all the resistors, alright? Just remove them, it's all good. Okay. I think I solved it. It's from here to here to here. There you go. It's horrible, I know. It's horrible, I know. And yeah, this one, okay, I know. From here, here, there, and here, and here. I'm just gonna move this around a little bit. Oh man, this is so bad. We can always polish it later, guys. Don't worry, okay? If you're getting PTSD, not PTSD, sorry. If you're getting OCD from this, just know that I don't really care. Oh shit, no, it's fuck. I'm more worried shipping this to Turkey. Yeah, I mean, at the customs, they will probably look at this and be like, the fuck is this? We draw this PCB, it's so shit. And then they'll just send it back or something, right? Okay, we're stuck again. Great. Fucking capacitor. Who needs a capacitor, bro? Okay, you know what? You know what? I know. Just gonna go through the other way, like this. Whoop, 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 boom. Best PCB ever, man. There we go. Make it a little bit better, a little bit bigger, and there you go. Can't you route the cable to the other side of the PCB? Is this what you mean? Boom. Ready to go to production. It's a little out of shape, but who isn't? Nothing is perfect, guys. So we're ready. We're ready for shipment. Look at this. It's so so bad. But you know, I can always fix it. The thing is, be ready. Remember, it's been 10 years since I did this, okay? Just please judge me based on that fact. I think I'm killing it right now. I never used this program before. That's another thing. I'm just like trying to defend myself for no reason. Gotta start somewhere. Put around the space bar I'm left. Hell yeah, bro. How do I do that? Text. Rat. Oh, you can also do images. Select an image file. Oh shit. Now we're in business, bro. Where's the TUI website? Oh, actually I have Hero. Oh shit, now we're talking. Now we're talking, bro. Doesn't have eyes, but we need eyes. Okay, it didn't work. How do I make this smaller though? 5 millimeters. Oh shit, dude, this is hot. Now we in business. Now we're talking. Just gonna put rat, not ratatouille or anything. Just rat. Just rat is enough. Guys, what do you think? What do you think? And be honest, is it like fire or nah? Giant board almost empty with rat log. Okay, let's take a look at the 3D. Oh shit. Oh my god. What the fuck is that? Oh yeah, I was not expecting this to be that big actually. Oh my god, that's not a pot. I used the wrong component, but who cares? Who cares? Oh my god, dude. And I think I used the top instead of bottom for the routes. It's cheesy. Oh my god, dude. Okay, this is like, well, we're getting somewhere with this. Okay, let's check the 2D view. I mean, it's pretty good. It's pretty good. It's actually fire. It's pretty fire, guys. I think you should learn how to route the cable from the bottom side as well, then it will be a good board. Yeah, let's do that. I think I can just like bottom layer. Is this like can I just copy everything from here to bottom layer? Like maybe just the routes. Layer, top layer, bottom layer. Oh, we can just change it like that. Okay, how do I select all the routes here? Design manager, nets, which I think you may use connectors. One is a wild assumption, of course, not everything, so you can jump cables without touching. Yeah. Okay, how do I select all the red stuff? Okay, I'm just gonna select all of them by hand. Next time I won't make this mistake, so we're still learning, okay? I'll try to verify everything and just maybe redesign this or maybe polish it or something and just try to ship it. Actually, I'm curious if that will actually work. Okay, there you go. Guitar pedal 2.0. Yeah, absolutely. This is just the start, okay? This is just the start. This is just the start. Oh my god, that looks horrible for some reason. Why does it look like that? It looks like it just glitched out or something. Oh, maybe... Oh shit. I don't know why that happened. Just like got reversed. Maybe that's why. This is a problem. Some cables may not touch the capacitors and resistors. May not touch? They are red colored, cables are blue. Oh. Oh, we need to put them in the... Okay, yeah. Just put everything on the top layer, bro. Just... We are always on the top, okay? We're always on the top, so I'm just gonna put everything on top. For now. But that's good to know. I need to think about that next time. Always on the top. Okay, that was actually quite fun. Alright, so the next stuff that I want to do, I want to make sure that I really need this 9-volt battery, because maybe I can do it without it, I want to make sure of that. I want to make sure that this resistor over here is also needed. Probably it's not. I can just remove it and it will probably work. The idea itself opens a lot of possibilities. Let's go play some factory, I guess. Enjoy, bro. And I need to add a pin for the microphone. So if I'm making a circuit, I'm gonna put everything in there. So there will be probably a switch or something that will allow you to switch between the microphone and the jack input. I will add another pot for the menu stuff, for adjusting the menu, whatever items, and yeah, bunch of stuff to do. I'm gonna ask about this circuit and everything. I'm just gonna like try to learn a bit more about this easy EDA, whatever. On the schematic there's checks you can run. Yeah, I can run them. Good point. I think the only thing you were missing was marking unused ports as unused. Okay, design manager. Okay, let's check the errors. How can I mark them as unused? Just ignore the warning. The X and the wiring tools. Oh. Okay. That's kind of useful, thank you. Okay. That worked, thank you. Okay, so other stuff, you're also not using them. X. Run again. Okay, that's that. Okay, save. I guess now it's all good. Of course it's not ready, but you know what I mean. All right. Guys, anything else? I think I did a lot of progress today. I think I can go and check any issues that I can close or comment on. Support jack input. This has been added now. Updated the memos in readme mdn. Let me add screenshots. Still working on the amp circuit. If you decide to print and ship to Turkey, in the case there is an issue, I may help. I would really appreciate that. How can you help? Cannot get it out from customs, but can move it to Turkey from Germany. Yeah, got it. That would be actually so sick. If I experience any problems, I'll hit you up, man. Not sure if printing this and just shipping it would take a lot of time, but let's see. This should be fine. I don't think this would cost less than 30 euros. Do you mean more than 30 euros? I don't think this would cost a lot. Yeah, it should cost less. Man, this looks so professional, but man, yeah, I don't know. Still got a long way to go, man. Alright, anyways. This was a fun stream. Since it's all on one side, if you know anyone with a CNC, it should be an easy cut. You know what? Okay. Not to flex or anything. But here's what I used to do. So this is like an old method, maybe you guys know. Like this is a circuit, like PCB, that I made like 10 years ago, maybe more than 10 years ago. You just like get this part and just like draw it with something. You just pour like, and then you use acid to melt it and shit, you know. And then you kind of have a little drill and you just drill holes and you put the components in, you know, like it's just super like custom made. And this was what I was doing, so I'm pretty much okay with doing this thing again, but it takes hella time and resources and everything, and shipping a PCB would be just easier. And this looks bad because it's just like handmade. But yeah, you guys know what I mean probably. If you dealt with electronics for a while now, you probably know this technique. It is called something, but I don't remember its name. Let's see if this is still running, by the way. It would be funny if it was still running, to be honest with you. It's still running, guys. Anybody know what this is? If anybody knows, I would be so surprised. Okay, let's try it. This is supposed to like magic. Magic clock. No, not a clock. It has text on it. I'm not sure if you can read it though. Put that on a fan. This is my workout. You can probably read it. Right? Yeah, this way it's better. Can I see its text but can't read it? Yes, it's my name. I remember some toys clocks like this in small shops in Turkey back then, yeah. Anyways, cool stuff. Guys, temperature, the weather is fucking hot here and I'm sweating, so I'm gonna go wash my face and shit like that. I'm dying here, so I guess thanks for tuning in. It was a nice stream. Hella progress. It's actually more progress than I was expecting the last week. It's crazy. But it's good. I have still a lot of things to do, so yeah. Namco, Jason, George, OIIO, something. Who else? I guess, guys, I appreciate you tuning in to the stream and just chatting and just helping out. And it's been a wild stream. I'll see you in the next one. All right. Stay on the grind always. Goodbye.